How you can maximize your inventory? We have demand forecasting, a technology that can predict the demand of your products in the market. Being an integrated system, there'll be no more inventory challenges in your supply chain.
It's all connected.
The future is here! With OCR technology, all you have to do is scan your documents, then all physical data will automatically be digitized at your fingertips.
Well, that's fast.
Claire will protect your banking system with fraud detection technology. Suspicious transaction will be automatically detected so that your banking staff can rectify it immediately.
Don't worry, we'll figure it out.
That's awesome.
I know, right? AI is definitely beyond what we've imagined. From face recognition that we use daily for online payments, to vehicle detection in law enforcement, and deep dive analytics for your customer that can help them make accurate decisions.
There's so much more that Claire can do. Let's collaborate and join us in your transformation to the future.
Education and science for humanity lay the foundation for a more inclusive and equitable world. Empowerment to lead and serve with excellence on a global scale. Universitas Kristen Duta Wacana, where history meets innovation, diversity drives excellence, and faith nurtures integrity. Located in the heart of Yogyakarta, we are proud to be a center of learning and research, accessible and connected to the pulse of the city. With over 4,000 students from across Indonesia, we embrace our rich diversity, making our university a melting pot of identities, cultures, and experiences.
Founded in 1962 as a school of theology, we have grown into a university in 1985. Our journey reflects the strength of our historical roots and vision for a brighter future. As a sustainable entrepreneurial research university, we focus on creating solutions, nurturing entrepreneurship, and advancing research that impacts society. Guided by faith, driven by integrity, and committed to excellence, Duta Wacana prepares graduates who are ready to serve the world.
With 7 departments and 17 study programs, including master's and doctorate degree, we are committed to academic excellence. Our students aren't just learning, they are growing as leaders, innovators, and changemakers. With state-of-the-art facilities and a vibrant student life, we make sure every student is ready to take on the challenges of tomorrow. We prepare students for the global stage, offering facilities and opportunities through various international programs. Our commitment to inclusive education ensures that everyone, including those who are impaired, has a place to grow and succeed. Duta Wacana. We honor our past, embrace the present, and look forward to a future where knowledge, integrity, and service shape the world. Join us on this journey of excellence.
Recording in progress.
distinguished guests, esteemed speakers, committee, and all participants. Good morning. Selamat pagi. Zhao Xiang Hao. Ohayo gozaimasu. Suprabat. Makadang umaga. A gratitude that is lovely morning. We are enjoying the third day of O-COCOSDA International Conference in Universitas Kristen Duta Wacana, Yogyakarta. My name is Ermerawati, and I will be your master of ceremony for today. Let me inform you that our last day of conference will have the last oral session, coffee break, country report, award ceremony for the best papers, the next O-COCOSDA host announcement, closing ceremony, lunch, and city tour of Yogyakarta. An early notice for those who are doing Friday prayer, the committee will escort you to the mosque, so please gather at the registration desk at 11 a.m. as the prayer today will start at 11:20 a.m. All right, coming to the main session for today, we are welcoming the session chair, Professor Satoshi Tamura. Please join me in welcoming him with a warm round of applause. Professor Satoshi Tamura. Yes, the floor is yours, Professor. Thank you.
Okay, good morning, selamat pagi. So it's a great honor of me to serve this oral session, the last session of oral one, and also the first session of today's Oriental COCOSDA program. So in this session, we have 5 presentations, 3 on-site and 2 online. So before the session, so I will inform you some information. So each presenter has 13 minutes for the presentation and also 3 minutes for Q&A. So we have a timekeeper over there, and the timekeeper will inform us some bell signs to, for example, 10 minutes, and 30 minutes, and 60 minutes. And as informed already, so we need to end this session on time. So we need to slightly hurry up the presentation and question and answering. Okay, so let's start the first presentation. So please come to the first presenter here. So the first presentation is titled Tonal Chord Creation in Jotsuma Angami, Compounds versus Non-Compounds. So are you ready? Okay, so at the first, please introduce yourself, then start your presentation.
Hello. Good morning, everyone. My name is Joni Guire. I'm from Indian Institute of Technology, Guwahati. And today I'll be presenting on tonal coarticulation in Jotsoma Angami, how Jotsoma tones behave when they come in contact, especially with the comparison from compounds, words, and non-compounds. Okay, so I myself is a native speaker of Jotsoma Angami. And in this talk, I'll be giving a brief introduction on Jotsoma language and followed by related studies done on tonal co-articulations, the method that we have used, and our study results, and I'll end with I'll summarize the works. So this, the highlighted with the red box is where the language is. This is the language area, where I have marked, and then the one to the right is the Nagaland map, which is from in the northeast India, and then the Jotsoma area, the study area, is marked in red colors. So Jotsoma language belongs to Tibeto-Burman language family, and it's spoken in the western Angami region, that is in the Kohima district, Nagaland state in northeast India. And according to the 2011 census, it was recorded that there are around 2,500 speakers. However, community record says in 2024 that there are around like 4,500 to 5,000 speakers. And this language has 4 level tones, which is registered, and with 6 vowels. So before going to Jotsoma language, Jotsoma is a variety of the standard Angami. So before going to Jotsoma, I would like to give a difference between the standard Angami and Jotsoma Angami. So here in the Jotsoma column, we see the difference, lexical differences shown here, where in Jotsoma we say for maize, zarsi, but then for standard Angami they say sheko. So there are like certain difference between the standard Angami and Jotsoma Angami as shown here. And when we look into the tonal difference of Jotsoma versus standard Angami, the Jotsoma Angami has 4 level tones, where we see that the word se, when you change the pitch of the word se, the meaning change. As you can see in the table that the meaning has changed to use, three, or meet, or snatch. And we did a preliminary studies on these tonal inventories, and we found out that there are 4 level tones. And then we used 16 speakers, equally divided in genders, and then we plotted it, and here it shows that there are 4 level tones in Jotsoma Angami, where we mark the high tone as T1, and then the lowest tone as T5. So we use T1, T3, T4, and T5. In standard Angami, research done by Teherja shows that she did her studies on standard Angami tonal inventories, and she found that there are like 4 level tones, because there is a 4 level. Some people say there are the literature study says there are like 5 level tones in Angami, but when they do the acoustic analysis, it was shown that there is only 4 level tones. So similar with this case, even Jotsoma has only 4 level tones. So according to the tonal inventory, there is no difference between Jotsoma Angami and then standard Angami. However, when we check into the morphological, morphotonological differences, we see the difference here, where the suffix, when the suffix is attached to a verb that has high tones, the suffix gets T1. However, in standard Angami, when the suffix is attached to a high tone, it gets T5. So this kind of contextual differences is being observed between standard Angami and Jotsoma Angami. So to study the tonal co-articulation, we have also some related studies that has been done on tonal co-articulation in other languages, like for Mandarin and Cantonese. The studies has been resolved that there are two directions of contextual effects, which is dissimilatory. It can be dissimilatory with anticipatories are dissimilatories and carryover are assimilatories. And also research done in Thai and Mizo shows that there is a mixed effect in the carryover effect. That is, carryover effect is the preceding tones affecting the following tones. And anticipatory effect is the following tones affecting the preceding tones. So in Mandarin or Cantonese, it shows that there is a clear distinction between anticipatory effect, where anticipatory effects is all dissimulates. However, in carryover effect, it assimilates. Whereas in Thai and Mizo, the studies reports that in carryover effect, they can, in anticipatory effect, they can either assimilate or they can dissimilate depending on the context. And also in Tianjin Chinese and Malaysian Hokkien, it also shows that there is a dissimilatory carryover effects has been reported. However, all these languages are countertones languages, and Teherja did a studies on standard Angami, the tonal co-articulation, where this standard Angami is also a level tones, and it shows that dissimilation happens in higher tones, whether it's carryover or anticipatory or carryover effect, it dissimulates. Whereas this carryover effect, kind of mixture effect is not seen in the other languages. However, all these studies, the co-articulation was seen in the disyllabic syllables. So we look into the trisyllabic words, how the tones will behave when the carryover effects and anticipatory effect comes from both ways. So when we did the study on that, we see a lot of mixed effect happening. So we want to see whether this effect difference we see from compound words and non-compound words. So the material that we designed was like, for the compound, we use the word tevedze, which is a compound words of a combination of chicken and egg. But when we say tevedze, it's called the egg. And for the non-compound, we use 3 monosyllable words, which is a sequence of syllables. And we embedded these target words into 3 environments, where we prepare for the set 1, that is for the compound words, and another set for non-compound words, where we embedded the target words into a sentence, into a carrier phrase, and also in isolation. So we asked the speakers to produce the target words in 3 repetitions. So here, overall, we use 21 distinct meaningful compounds and also 21 meaningful non-compound words. And the data was recorded in 2 sessions. We used the syllable types of CV, 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 except in 2 cases where we use VC, CV, CV. And here in the graph, we show that there are 18 speakers used. However, 9 participants participated in both the experiment and unique participant in compound and non-compound. Okay, so we extracted the F0 values, normalized it, and we used ggplot for visual explanation, and we also use LME and Bonferroni post-hoc for our statistical analysis. And the first results, our result shows that here we divided the results in 4 plots, where we put the V1, the tones of the first vowels, the tone of the second vowels, and this is the tones of the third vowels. And we put the middle tone as T1, changing the initial and the preceding and the following tones. So we can see the green line and then the gray line in the middle tones, where we see a dissimilatory effect, and then we also see that there is an anticipatory raising. Is more in compound words, which is the dashed line, which shows that anticipatory raising is more in the compound words. And here the effect on tone T3, we see that anticipatory raising is more in compound words, where we can follow the green line and then the gray line, where the solid line is completely different from the dashed line. So this shows a different effect on the compound words and non-compound words. Also the effect on T4, following the red and the green solid line, we see that there is a dissimilatory anticipatory effect, where anticipatory lowering is seen more in the compound words, that is the solid line. Effect on T5, here the effect is very minimal, and we see a marginal dissimilatory effect where T5 is lowered by the following T1, that is the gray line, and anticipatory raising is seen more in the non-compound words in this case. So we also want to see why this effect is difference in compound and non-compound. So we look into the durations, and we see the difference in the duration between compound and non-compound, where in compound words, which is the red color, the compound words, the S1 is, I make a mistake here. In compound words, the S1 and S2 is short and S3 is long. However, in non-compound word, the S1 is long and S2 and S3, that is the syllable 1 and syllable 2 is short. So the statistical analysis also supports that there is no distinction in syllable 1 of compound and non-compound. I mean, there is a significant difference seen in the first syllable of compound and non-compound, and there is a mixed significance in the second syllable between compound and non-compound. However, the third syllable shows that there is no significance difference. So we also look into the compound and non-compounds of the F0 point, taking 3 midpoint in each syllables, where is this for the first syllable, and this one for the second syllable, and this is for the third syllable. And then the highlighted tones in red colors are where the significance is found between compound and non-compound. So these are the 21 tonal combination, first syllable, and then for the second syllable. So we have seen some significance difference here in compound words and non-compounds. So to summarize, I want to say the talks, the anticipatory effect is more prominent than the carryover effect. So our focus was more in anticipatory effect. And then the effect on high tone on low tone is dissimilatory, and low tone on high tone is also dissimilatory. High tones on high tones is also dissimilatory in nature. And dissimilatory anticipatory raising are more prominent in non-compound words. Pitch lowering is more evident in compound words. And we also see that the duration as a cue for this contextual variation, where we see non-compound words are more prone to pitch raising, which can be a result of longer durations. These are my some references. Thank you.
Okay, thank you very much. Is there any quick question from the audience?
So thank you. Can you hear me?
Oh, yes. Yes, ma'am.
So thank you for your presentation. So so in this study, you analyze the difference between compound and compound word in Jotsoma, right?
Yes.
And this is aligned with the standard Angami language. So it's a similar characteristic when is the difference between compound and compound word between Jotsoma and the standard Angami language?
We haven't looked into the standard difference between comparison between compound and non-compound in standard Angami. However, we have looked into the tonal articulations in standard Angami in disyllabic words.
Okay, but you have not seen about the compound?
No, ma'am, no.
Thank you.
Okay, so due to the time limitation, if you have any question, please ask her in the coffee session. So let's thank the author again.
Thank you.
Okay, let's move to the second presentation. If the presenter is here, please come here. The second presentation is titled Improving Multi-Speaker Transcription for Live News Broadcasts with Canary 1B and Pioneer Diarization. So at first, please introduce yourself, then start your presentation.
Check. Okay. Good morning, everyone. It's an honor for me to be able to present our latest work on this International O-COCOSDA Conference of 2025. And my name is Alvin, and I will be, on behalf of my team, I will be the representative to present our latest work for speech processing about the improvement of multi-speaker transcription for live news broadcasts with Canary 1B and Pioneer Diarization. So in this work, we explore the integration of NVIDIA's Canary 1B to the Pioneer Diarization model. So we evaluate how this combination could enhance real-time performance on transcribing and diarizing live news broadcasts. Okay, this is the outline that the session will go through. First, we will explain the reasoning why we came up with the solution through the introduction, and then we move on to the related works that we use to come up with the solution and how we implement it, and how are the results that we're obtaining, and also the conclusion and the future works that can be further enhanced. So, right, starting with the introduction, what is transcription and diarization basically is. So transcription is basically a task where you assign a system to convert an audio input that contains a speech or a human speech to a human readable text. So the input would be a sinusoidal wave, a sound wave, and then convert it to human readable text. And diarization, on the other hand, is basically a task where you separate on that audio input, you separate segments of the speakers. So it's being chunked on a specific timestamp where each timestamp contains each of the specific speakers. So it's like given an audio input that consists of many speakers, then you separate those audio into different segments where each segment contains each of their own speakers. So combining these two architecture, we are aiming to improve accessibility through real-time captions. We're also enabling efficient content archiving for future reference. And lastly, we will also be able to support analysis by organizing information from multiple speakers. And here is the related work that we're looking up to. We refer to the architecture called WhisperX. WhisperX is basically a framework that extends Whisper, or Whisper is basically OpenAI's ASR model that extends its capabilities to not just only transcribe audio, but also enabling it to diarize as well. So not just being able to transcribe, it also able to separate the speaker's voice by incorporating Pioneer for the diarization. So how is it different from our approach? Basically, this WhisperX mainly relies on OpenAI's ASR model, which is the Whisper. And our approach will be using NVIDIA's Canary 1B instead of Whisper. And also, WhisperX come up with its own architecture, like as you can see on the screen. And it's different from what our approach. We have our own architecture that we going through. Okay, and next is PioNote. PioNote is the model that we use to diarize, to separate the voices of to distinguish the speakers on an audio input. And it is crucial for enhancing the transcription quality, especially in environments where there are multiple speakers that are interacting rapidly, like for live news, for example. So it is actually a library that's being widely used on speaker diarization. It's leveraging a pre-trained deep learning models for speaker embedding and clustering. Okay, and this is the ASR model that we use. We use Canary 1B. It is, at that time, it was a state-of-the-art ASR model that has shown superior performance compared to the rest. As you can see in the rankings, it places on top in a couple of different metrics, like for example, word error rate and other metrics as well. And moving on to the implementation, we propose an architecture that integrates both Canary with the PioNote. So we come up with integrating the ASR model of Canary 1B and PioNote for the diarization to be able to handle complex requirements of live news transcription in real-time performance. Yeah, so this is the overall architecture of our pipeline. So we take audio input and then we pass it in onto the diarization model for it to distinguish between speakers. Like as you can see, there's speaker 0, speaker 1, speaker 2, and speaker n, and so on and so on. And these chunks of speakers audio, we pass it in into Canary 1B ASR, but with VAD chunking as well. So VAD chunking is basically the algorithm where it only takes the important part of the audio, where it only contains the speaker's voice. It's like a filter mechanism where we only take the audio that contains the speaker's actual voice, not unnecessary noises or even no noise at all. So we'll make sure that we only process the important ones. And once we are done with the transcription, the end result would be the transcription and the speaker and also the timestamp as well. And this is the implementation for diarization. It has the output of, the input is an audio and the output would look like this. The start second, the ending second, and the speaker ID. So we don't specifically assign the specific name of the speaker. We assign distinguished ID like speaker 5, speaker 4, speaker 3, speaker 2, speaker 1, and so on, depending on the input of how many speakers are there actually. And this is the combination with VAD and transcription plus the diarization as well. So we're getting the result of start time, the end time of each chunk, and then the speaker, and also the text, the generated text by ASR. ASR is carried out for each speaker segment from the diarization result in order for us to be able to get the human readable text. And here is the result that we're getting. We're actually comparing these two models. First one is Whispers. We actually compared with the large one. So as you can see in this comparison, right, the WR seems to be competing, but in terms of character on CER, Canary outperforms Whisper very good. So yeah, it seems that Canary 1B is more superior than Whisper when it comes up to this task. And here is the example of the results of the ground truth. Like as you can see there's the actual ground truth. Ground truth is the actual transcription. It says that economic advisors have at times blah blah blah, and the Whisper correctly identifies the word advisor. However, Canary mistakenly identified it as advisors. However, in the next chunk, it correctly identifies word instead of R, like whisper, and so on and so on. So this is like the small parts of the evaluation. And this is the result, combining transcription and diarization. So there's also a timestamp on the left column, and there's a speaker's identification, speaker's ID, speaker 4 and speaker 3, and also the transcription as well. This is what the entire pipeline is resulting. Okay, and here's an example of our live news transcription and diarization. Notice that there's a subtitle below the speaker 5 and its transcription. So speaker 5 is the job of the diarization, while my team of political and so on is the job of the ASR, of the transcription. And if you can take a look.
All fresh fruit, 69% of vegetables, according to the USDA, come from Mexico.
Yeah.
These are voters who just put Trump in office because they trusted him more on the economy. How should they be reading a promise like that from Trump tonight?
Oh, man. Well, you know, I was always astounded.
All fresh fruit, 69% of vegetables, according to the USDA, come from Mexico.
Yeah.
These are voters who just put Trump in office.
Can you play again? Sorry.
Because they trusted him more on the economy. How should they be reading a promise like that from Trump tonight?
Oh, man.
Yeah,
well, you know, I was always astounded.
Yeah, notice how the transcription actually changes the speaker ID, right? From speaker 5 to speaker 4. And can we play again?
To say that he ran on, I'm going to lower inflation, when if you look at the policies, tariffs included, it's all about raising inflation, right? And it's also raising the dollar, which is going to have a larger impact in the market. I want to just say, though,
He did it his last time in office. He definitely put tariffs on, but there were certain ones where advisors could talk him out of that. What does that look like in round 2?
Well, Donald Trump has basically two core policy beliefs. He believes the border should be secure, and he believes in...
See that the speaker all changing again to a different speaker. So this one is assigned the ID of speaker 3 and so on and so on. So you can take as many speakers as you want, and then the diarization would separate them and give them a unique ID. And the transcription would also run well on this pipeline. Yeah. And to conclude our works, so Whisper actually remains reliable on providing a comprehensive coverage of audio, and while Canary also shows potential for improving recognition of specific terms of challenging speech patterns. However, when it comes to language coverage, actually Whisper's already a few steps ahead because it actually supports over 100 languages, while Canary only supports 5 distinguished languages. So this suggests that Canary could benefit from further fine-tuning or integration with Whisper to address its limitation mainly in terms of the language coverage to maximize its strength and in transcription tasks as well. And for future work, we may focus on optimizing the integration of Canary with PyNote and addressing transcription gaps and exploring hybrid approaches that combine the best of both worlds to improve the overall quality of live news broadcast transcription and diarization as well. Thank you for your time. I think that's all.
Okay, thank you very much. So is there any question from the audience?
Okay, thank you. So looking at your demo, it's interesting for me, and it's a quite job. You have done a great job. But I have questions looking at the result. So it is a live transcription system, isn't it? Yeah. But when you display it, so the transcription is complete before the speaker finish saying these sentences. Is it because you did it before, or how is it so that the transcription comes in a full sentence while the speaker is just saying maybe 3-4 words before finishing it? Okay, will you explain that? Thank you.
Okay, thank you for the question. For this particular example that we shown is actually we did it not live. So we take the full input first, and then we proceed to pass it on to our proposed architecture. So for this example that I shown you is basically not live, but somehow we also tested on a live pipeline and it works, but I didn't get the chance to find it where I think I lost it. So we decided to show in the presentation that the ones that are not live actually.
Okay.
Hello.
Hello.
Yeah. Really appreciate your work with Ibu Titi. Yeah.
Yeah.
So I have a question. For the future work, probably what is the greatest challenge if we will want to bring this to the live news, real time? What are the challenges, with the dynamic environment? Yeah, by integrating the Canary with the PyNode. Yeah.
Okay.
PyNode. Yeah.
Okay. Thank you for the question, Mr. I think the greater challenges for this future work would be the optimization on how do we actually integrate this to distinguish two different models, because when we're talking about machine learning models, oftentimes it's actually a challenge for ourselves to make it real time. So there might be further optimizations that we could do to be able to make it actual real time without any latencies at all. I think our main focus would be latency.
Okay, so unfortunately time is up, so let's thank the author again.
Thank you.
Okay, so let's move to the third presentation. So presenter, please come here. The third presentation is titled Neural Network-Based Speech Emotion Recognition for the Indonesian Language.
Thank you.
Okay.
Good morning, everyone. My name is Kurniawati Aziza. I'm from the Faculty of Computer Science, University of Indonesia. I'm excited to share our research on neural network-based speech emotion recognition for Indonesian language. This actually primarily the work of my two students, Muhammad Iqbal Asrif and Muhammad Alif, whom I had the pleasure of supervising. Unfortunately, they are unable to join today, so I will be presenting this work on their behalf. Okay. Here is an overview of our presentation today. We'll start with an introduction to the field of speech emotion recognition, then move on to the methods we use in the research. Next, we will discuss results and analysis of our experiments. Finally, we will conclude with a summary of our finding and future work. So, speech emotion recognition, or SIR, is the process of enabling machines to understand and respond to humans' emotion through vocal cues. It's a pivotal technology in the realm of human-computer interaction, allowing for more natural and empathetic communication between human and machines. This technology has the potential for various applications, such as call center management, healthcare, and human behavior assessment, and also robotic. So our work was motivated by the fact that SIR development still faces challenges, particularly for low-resource languages like Indonesian. The Indonesian languages has inherent complexity as there are a diverse dialect and phonetic variations which are still less explored in many research. So this creates a need for a model that can accurately capture and understand ones in Indonesian speech. Besides, limited data for annotated emotion speech is also an issue for Indonesian language. So to overcome this issue, we are trying to leverage deep learning model capacity to learn complex patterns from small data sets. So we use handcrafted feature to be fed to the deep learning models. So for a deep learning model, we use only two fundamental DNN models, which is MLP, multi-layer perceptron, and also LSTM. So we use the handcrafted feature as input of this model because we have only limited data set that's called low resource data set. So basically, deep learning usually need or data hungry need a large amount of data set. So the solution is to use a handcrafted feature to be fed to the model. So for the data set, we use IndoWave sentiment data set, consists of 300 audio files from 10 actors, 5 male and 5 females. Each actor performed 5 emotional categories with 2 different sentences 3 times. So there are 5 emotions, which is neutral, happy, surprise, disgust, and disappointment. We extracted several handcrafted features to train our deep learning model. The first is the pitch feature. In speech emotion recognition, pitch is an important feature because it reflects a speaker emotional condition perceived as a sound frequency perceived with physiological and psychological changes during emotional expression. So vocal cord tends to have a vibration rate very altering voice speech. High arousal emotions such as anger, joy often raise pitch, while low arousal state, for example, sadness and calm tend to lower it. To accurately estimate and analyze pitch from audio signal, we employ autocorrelation on center clips frame, a method proven effective to pitch detection in practice. Okay, the next feature is harmonic feature. The emotional state has a close connection with additional excitation signals other than pitch. Harmonic are important feature for analyzing emotional speech, especially during anger and stress. When speakers show anger and stress emotion, their voice often include extra excitation component beyond the fundamental frequency. This component appear in the spectrum as harmonics and cross harmonics, changing the speech acoustic characteristics that are useful for distinguishing emotions. To extract and emphasize this harmonic component, we apply a median filter designed for a specific window size L. So the other feature extraction is energy, pause, and finally a central moment. So energy in speech signal was considered in relation to its loudness. This is very important as the increase or decrease of energy show a representation of feeling or emotion. So it can help indicate certain emotions. We use RMSC to calculate the energy. Next is pause. Silent portion in the audio signal often show high correlation with feeling, so we employ it. Pause duration in speech indicates emotional state. For example, shorter pause often indicate high arousal emotion like anger and excitement, while longer pause usually for sad and calmness. Finally, we also extract central moment feature to summarize audio dynamic information such as mean and standard deviation of the amplitudes. Okay, here is the experiment. These are our experiment steps we can see, and also the link of the source code we can see in here. And here is the performance of MLP. We can see that we have an accuracy of 75% and F-score is 72%. So we can say that the performance of feature extraction can actively be used for reprocess and transfer to the model of deep learning, helping achieve effective results even with limited amount of data. So on the right is the most important feature that contributing to the classification is speech standard deviation or a speech variation, and that is the important feature that we can gather. And then the result for LSTM is in here. So LSTM has a lower score, but still quite moderate result. So this is lower compared to the MLP models. So this is the example of the audio and emotion label. Maybe we can play.
Kualitas HP ini cukup bagus. Kualitas HP ini cukup bagus.
Kualitas HP ini cukup bagus. Kualitas HP ini cukup bagus. Kualitas HP ini cukup bagus.
So that's the example of our data set with label emotion and also the prediction from the model using MLP and also LSTM. So actually our work is based on the reference which is from SAHU 222. So we compare our model with the SAHU. So our model have a better performance using a relatively smaller data set compared to SAHU. Our model use 300 audio files, and SAHU use around 7,800. So this is the confusion matrix. We can see in the diagonal seems that the MLP and STM model can accurately predict the label, while the SAHU is lower performance compared to our work. Okay, so in conclusion, both MLP and LSTM are effective for Indonesian SIR when trained with our handcrafted feature. So pitch is the most, and also another conclusion is the pitch is the most important feature for this classification. And for future work, maybe we can improve the model ability to distinguish subtle emotion like disgust and disappointment, and also refine the model architecture, because right now we only use a very basic model, which is MLP and also LSTM. So, and then maybe we can validate finding a larger or more diverse data sets. Thank you.
Okay, thank you for your presentation. Is there any question from the audience? No question?
Okay, thank you. Very good research. I have basically curiosity about these neural networks, which often requires a large, very comprehensive label data set. So, Ibu Titi, how did you construct or adapt the suitable emotional data set into this? I think that will be very challenging, and I would like to hear from you.
Okay, thank you very much for the question. Yes, actually, deep learning model usually is data hungry. So to be able to have a very good performance, deep learning need a large amount of data set, because they can learn the feature directly in the model. But if we have only a small amount of data set, we can use handcrafted features. That's the purpose of our work in here. So instead of using directly audio such as MFCC or Mel spectrogram directly, we extract the feature from them first, such as pitch, energy, harmonics, and also central moment, before we fed to the deep learning model. So that's the solution for classification emotion in this work. So we propose handcrafted feature that usually used by classical machine learning, such as random forest, and it's not deep learning, but we use that to see whether deep learning also can handle the classification with a small amount of data using the handcrafted feature extraction beforehand. So that's the purpose of our work.
Okay. So I have a simple question. So have you tried to compare the results if you use some deep learning based SER model built using the other language, for example, English or Mandarin, because they have a large data set and also they have a good performance SER model. So have you ever tried to use it and compare it?
Yeah, actually it will be perfect if we compare many architecture, also compare with shallow learning such as random forest or other model before. And also it's better to have a comparison with deep learning with non-handcrafted feature, but actually for this work it's not yet done. Why? Because actually this work is for final project of my student in my course, spoken language processing course. So we only have 6 months to work on this, and so the study is not comprehensive. So if we, for the future work, if they're interested to do it in the final thesis, for example, we can improve our model.
Okay.
Thank you.
Okay, so thanks, dear author, again. Okay, so let's move to the fourth presentation. The fourth presentation will be held online. So the author is already online.
Hello, hello. Yes, I'm here.
Not yet. Oh, okay. So the first presentation is titled Multilingual Multitask Learning with Gradient Multiplication Method for Local Language in Indonesia. So if you are okay, please start your presentation.
Sorry, can you help me share my slides?
And now we can hear you, so please start your presentation.
Oh. Okay. Good morning, everyone. My name is Wilbert Fangdeset. I'm from Bandung Institute of Technology. Today, I'm happy to present my research on multilingual multitask learning with gradient manipulation method for local languages in Indonesia. For the next slide. Actually, I can't see my slide in Zoom. I think haven't shared in the Zoom meeting. Sorry. Hello. Okay. For the next slide. Oh. Wait, I think that's not my slide. It's Yep. Okay, move on to the next slide. For a bit of introduction, multitask learning is a machine learning technique in which a model is trained to learn and solve more than one task by leveraging the similarities among the tasks. So multitask learning has been widely used in various studies. However, there are still optimization challenges that have not been well addressed. These challenges arise due to different learning rates across tasks, conflicts between tasks. Conflict refers to a condition where the gradient of one task negatively affects the performance of the other task, the dominance of gradient magnitude from one task over the average gradient, and high positive curvature in the direction of task gradient. Next slide. Okay, this research focuses on local languages in Indonesia because there are still a few studies that apply multitask learning methods to these local languages. Indonesian local languages were chosen also because of their diversity and their limited resources, which make them challenging yet valuable for this research. Therefore, the experiment we carried with the use of the multitask learning approach on Indonesian local languages, making it multilingual. The next slide. Okay, here are the example structure of the multitask learning. There are set layer and task-specific layers. Set layers are layers designed to capture the common features across all the tasks. Usually consist of embedding layers, transformer layers, and or fully connected layers. For the task-specific layers, these are dedicated to each task, usually consist of fully connected layers and output layers with activation function of each type of the task. Next. Okay, here in my research, I want to see how does the performance of the gradient manipulation methods compare to the naive multitask learning method in terms of multilingual multitask learning quality. So gradient manipulation method is a process of modifying the gradient values, either the magnitude or direction of a function within a machine learning model. Next slide. So in this research, we use several gradient manipulation methods. The first one is PC grid. How PC grid work is when conflict gradients occur, PC grid will project the direction by calculating the cosine similarity between the two gradients, forming a normal plane. As we can see in B, the gradient is projected to make a normal plane. And when non-conflicting occurs in C, it will do nothing. Next one. The second one is gradient fixing or grad fact. This method is utilizing the relationship between tasks to set a similar objective. So by setting a similar objective between two tasks, the tasks adaptively align their gradients to achieve their objective. In A, we can see that what happens if there's a conflict. The PC grad method will, on the left side, PC grad method will perform a normal plane, while grad fact will align the gradients to achieve a certain objective. For the B, when there's no conflict, PC grad will do nothing, but grad fact will still adjust the gradient. Next one. Okay, the third one we use is CA grade or complex average gradient descent. This is the method is finding a new optimal factor within a local region based on the average gradient. So around the average of the two gradients, and it will find the optimal factor within the circle as can be seen by the image. Next one. For this research, we use 4 methods. The first one, there's 4 methodology. The first one is dataset preparation. The second one is multitask learning model and gradient manipulation method preparation. The third one is experiment, and the last one is evaluation. Next. Okay, for the dataset preparation, we use three different tests, which are sentiment analysis from Nusa-X sentiment dataset. The second one is emotion classification from Nusa Translation EMOT. And the third one is topic modeling from Nusa-X sentiment. Here we use a total of 17 different languages in this research. Next. For the model and method preparation, the multitask learning model is built using SLM Roberta base as the base model, which support training on multiple languages. The model consists of 3 linear heads, one for each task, along with the loss function to calculate the loss per task, and forward function to perform prediction and compute overall loss. For the optimizer, we use ADMW. It's used to update the model parameters based on the computed gradients in order to minimize the loss function. And here are the environment setup and the parameters used for the experiment. Here we run 2 types of batch size. The first one is which are 8 and 16. Next. Okay, the experiment will be conducted using these methods. For the vanilla method, vanilla here is without any gradient manipulation, and the PC grade, grad fact, and CA grade is already explained before. And for the trained languages, we train the model using 3 languages, which are Javanese, Madurese, and Sundanese. And for the test languages, we test the model 2 times. The first one is with their trained languages, which is Javanese, Madurese, and Sundanese. And the second one is other languages in Indonesia. The next one. For the evaluation method, we use confusion matrix, which is macro F1, which is calculated using the average precision of the predicted class and average recall of the true class. Macro F1 is used to illustrate the balanced performance of its model result. Okay, next one. For the first experiment, we use the batch size of 8, trained on Javanese, Madurese, and Sundanese languages, and tested on Javanese, Madurese, and Sundanese. The first result showed that the PC grade achieved the highest total macro average F1 score of 72.85, and PC grade method and grad fac method is also obtain a higher total average macro F1 score compared to the vanilla method. Next. For the experiment 2, it's the same experiment but with a batch size of 16, tested on the same languages. For this experiment, CA grade achieved the highest total average macro F1 score of 71.61, and 3 of the gradient manipulation method obtained higher total average macro F1 scores compared to vanilla method. Next. The next experiment is with a batch size of 8, trained on the Javanese, Madurese, and Sundanese language, and we tested on other languages in Indonesia with a total of 17 total languages. Here we can see that PC grade achieved the highest total average macro F1 score of 65.99, and all of the 3 gradient manipulation method obtain a higher total average macro F1 scores compared to the vanilla. Next one. This is the last one with the batch size of 16, trained on Javanese, Madurese, Sundanese, and tested on other languages. Here we can see the PC grade is overwhelming, got the highest total average macro F1 score across all the tasks with the average of 67.65. And all of the 3 gradient manipulation methods obtain a higher total of average macro F1 scores compared to the vanilla method. Next. So in conclusion of this research is gradient manipulation methods such as PC grade, grad fac, and CA grade is proved to be more effective than the vanilla method in improving the quality of multilingual multitask learning, and pre-trained language model adapted with gradient manipulation approaches do not experience a significant decrease. As you can see, the scores is not really difference in macro F1 scores when applied to unseen Indonesian local languages. And among the gradient manipulation method, PC grade demonstrate the highest overall performance across the tasks compared to grad fac and CA grade. Okay, next. I think that's all. Thank you for your attention.
Okay, thank you very much for your presentation. So is there any quick question from the audience?
Okay, thank you. So I have 2 questions. So the first one is, I wonder where the gradient surgery is applied. Is it applied on all layers, including the downstream tasks, or is it only applied on the shared layers? That's the first question. I think my second question is out of my curiosity, I wonder if there's a way to measure how conflicted gradients are between 2 or multiple tasks. Thank you.
Okay, for the first question, it's applied the PC grade, grad fac, and CA grade applied on the shared layers on the multitask learning. It's not applied on the task-specific layers. And for the second question, sorry, I didn't really understand the question. Can you repeat it or elaborate it?
Yeah, sure. So is there any way to measure how conflicted the gradients are between multiple tasks?
Oh, yeah, there's a way to measure the conflicting gradients between the multiple tasks. It's on the actually it's from many previous research has done that and shown that the conflicting tasks between two tasks, there's what we call give a performance negative impact. As we can see, if we describe it in the gradient, the direction of the gradient between the two tasks is not aligned, make it a negative performance for both of the tasks. I think that's all.
Okay,
thank you for the question.
So because we are now behind the schedule, so we want to move to the last presentation. Okay, so let's thank the presenter again. Okay, so last presentation, the OSI is online already. The HIP's presentation is titled Development of ACHEX for Sentiment Analysis using the BART-based model. So, okay. Okay, so if you are ready, so please start with the presentation.
Good morning, everyone. My name is Doni Sumito Sukwiswo from Universitas Syah Kuala, Aceh, Indonesia. Today, I will present our research titled Development of ACHEX for Sentiment Analysis using a BERT-based model. Our goal is to enhance sentiment analysis for the Achenese language, a local language rich in culture, heritage, but limited in natural language processing resources. Introduction. In 2019, BERT introduced bit-directional training that effectively capture complex contextual dependencies. By 2020, BERT for Vietnamese show that adapting the tokenizer and vocabulary is crucial for language with unique linguistics. In 2021, Indo-NLG and Indo-BERT advanced Indonesian NLP top regional language were still underrepresented. Then in 2023, Arsenberg demonstrated the value of language-specific adaptation to capture dialect and structure nuances. Finally, in 2024, Nusaberg extended convert to local language, including Achenese. However, limited data caused the performance of sentiment analysis to be weaker. This background motivated us to develop ACHEX BERT, a model adapted from Indo-BERT and trained using mass language modeling and on the newly developed ACHEX corpus. Objective. Our research has four main objectives. Number one, compile the ACHEX corpus, which include text from literature, traditional custom, customary law, folklore, oral tradition, Wikipedia, and YouTube comment. Also supporting culture preservation. Number two, develop an Achenese specific tokenizer to Achenese vocabulary to reduce out of vocabulary token to better capture morphological and lexical feature. Number three, retrain Indo-BERT base using mass language modeling on ACHEX corpus to improve morphological representation of Achenese. Number four, fine-tune and optimize ACHEX BERT for multi-class sentiment classification with three labels: positive, negative, and neutral. The goal is to achieve better performance than baseline model. Achenese dataset. The ACHEX corpus is the foundation of this work. Online data were collected using web crawling, while offline text were digitalized manually. It was compiled from 41,627 sentences remain for MLM pre-training. For sentiment analysis, we manually label 3,725 sentences in three classes. Labeling was done by 6 native Achenese annotators, followed by validation by another native speaker to ensure culture and linguistic accuracy. We also include the Nusaik Achenese dataset, consisting 1,000 labeled sentences for benchmarking and cross-dataset evaluation. Combine both dataset ensured that Aceh Expert was tested not only on a newly developed resource but also again established benchmarks such as Nusabet, providing a fair and more comprehensive evaluation. Methodology. The research framework consists of 4 main steps. Step 1, corpus compilation. Develop the Aceh corpus from diverse sources, ensure culture and linguistic breadth for better pre-training. This ensured that the corpus was consistent and high quality. Step 2, tokenizer development. Sun in the bird, tokenizer was not trained on Aceh niche. Many local words were out of vocabulary. To address the limitation of citing tokenizer trained primarily on Indonesian and multilingual corpora, this study developed a custom tokenizer specifically for the Acehnese language. Step 3, enhance pre-training. While in the bird base was originally trained on large-scale Indonesian text, its capacity to represent Acehnese morphology and vocabulary remain limited due to difference in linguistic structure and regional expression. By continuing retraining on the Aceh dataset, the model learned Aceh-specific vocabulary and grammar, improving its morphological representation and contextual understanding for downstream tasks like sentiment classification. Step 4, model optimization. This takes fine-tuning Aceh Expert for multi-class sentiment classification while improving contextual understanding and robustness through pre-trained Aceh linguistic representation. Pre-processing. Text pre-processing include lowercasing, accent, and punctuation normalization, removal of number and symbol, white space correction, and duplicate elimination to ensure consistency, reduce noise, and improve the overall quality of the Aceh corpus. Tokenizer. Following the pre-processing step, the text was tokenized using the word-based algorithm to segment word into sub-word units suitable for model training. To ensure vocabulary relevant and reduce noise, only tokens that appear at least 10 times in the corpus were retained, resulting in a refined vocabulary 8,961 tokens. These tokens were then integrated into the Indobird-based tokenizer, where 4,765 new tokens were successfully added without overlapping with the original Indobird vocabulary, thereby expanding the tokenizer capacity to represent Acehnese linguistic features more accurately. MLM pre-training. Aceh Expert was first pre-trained using the mass linguistic modeling objective on the Aceh corpus to build a strong foundational understanding of Acehnese linguistic structure before downstream fine-tuning. The model architecture followed the Indobird-based configuration comprising 110 million parameters with 12 encoder layers, 12 attention head, and hidden size 768 dimensions. Each token was represented as 768 dimension vector and processed through cell attention and feed-forward layer. In line with the bird pre-training strategy, 15% of tokens were randomly selected for masking, 80% replaced with mask token, 10% with random token, and 10% unchanged. This pre-training phase enabled Aceh Expert to get bit directional contextual representation of the Chinese language, serving as a solid base for subsequent fine-tuning on downstream sentiment classification tasks. Fine-tuning classification. The process began with raw text input, which is tokenized using the Aceh Expert tokenizer. The special token CLS and SEP are appended to indicate the start and end of the sequence, and the text is transformed into token IDS along with the corresponding attention mask. These inputs are then processed through 12 transfer encoder layer, where contextualized representation of the token are generated. From this state, the full output corresponding to the CLS token is extracted to represent the overall semantic content of the input sentence. The full vector is subsequently passed to a dropout layer, probability 0.1. Finally, a fully connected layer project to 760x dimensional vector into the 3 target class to generate the final sentiment prediction. Result: for MLM evaluation, daring MLM pre-training Aceh Expert achieved an evaluation loss 4.36, accuracy 34.7%, and perplexity 78.35. These values are marked better than in the bird and Nusa bird. It indicates that pre-training on Acehese text significantly improved contextual understanding. The model was tested on sentence containing the mask token, predicting word based on context. This example highlights Aceh Expert ability to capture semantic and syntactic context, demonstrating that MLM pre-training with the Aceh corpus effectively equip the model to produce natural prediction. For sentiment classification, on the Aceh dataset, Aceh Expert achieved 82.50% macro F1, outperforming baseline model. On the Nusa dataset, it achieved 81.89 macro F1, slightly higher than baseline model. This result confirms that domain-specific adaptation benefit low-resource language. Error analysis. Although the model performed well, overall misclassification occur mainly in sentence with irony or sarcasm, short or ambiguous neutral sentiment, and non-standard spelling or regional variant that were not well represented in the tokenizer, reducing model accuracy. For example, bereh ji tapi hana jamin jet kerja, meaning he is good but that does not guarantee he will be able to do the job, was classified a positive instead of neutral, indicating the difficulty in capture implicit contrastive meaning. Conclusion: we developed Aceh Expert, a bird-based model adapted for the Acehese language. Through the creation of the Aceh corpus and a custom tokenizer, we successfully improved representation of Acehese linguistic pattern. Beyond performance, this research contribute to language preservation, enabling NLP applications such as sentiment monitoring, recommendation system, and digitalization for local culture. Future work include expanding the corpus and training large model variant. Thank you very much for your attention.
Okay, thank you very much for your presentation. So is there any quick question from the audience? No question? So I have one question. So you introduced the HX database in addition to the NusaX database. At that time, so you mentioned we have 3,725 labeled data, and also you have roughly 41,000 unlabeled data. So in this experiment, so you didn't use the unlabeled data for training, right? Can you hear me?
Yes?
Can you hear me?
Yes, I can hear.
So my question is, did you use the 41,000 unlabeled data in the HX dataset for model training? You didn't use the one?
Yes, for the dataset Achenis, we collect 41,627 sentence for MLM retraining.
Okay, I see. Okay, so if no questions, so let's thank the author again.
Thank you.
Okay, so now I'd like to close this session. Finally, so I'd like to ask you to appreciate all the presenters, all the presentators and also the participants who joined the discussion. Thank you very much.
All right, thank you, Professor Satoshi Tamura, for being the session chair. Please give him a warm round of applause. All right, and let me welcome Dr. Rosa Delima Eskom MCom, the Vice Rector of Academic Affairs and Research of Universitas Kristen Duta Wacana. Bu Rosa, enjoy the conference. All right. Yes, ladies and gentlemen, the snacks and beverages are served. So please take the opportunity to relax, refresh, and network with fellow participants. And the next session will begin promptly at 9:50. So we kindly invite everyone to return to the venue on time. So enjoy your coffee break. Okay, ladies and gentlemen, before going to the next ones, allow me to remind those who will do Friday prayer to gather at the registration desk at 11 a.m. as the committee will escort you to the mosque. All right, now let us proceed to the next agenda, which is country report. Therefore, let me invite the convener of O-COCOSDA, Professor Sakriani Sakti. So, Professor Sakriani Sakti, the floor is yours.
Okay, good morning, everyone. Now we are starting in the session of country and region report. So this session is very unique compared to the normal conference because only Oriental COCOSDA that have the this country and region report where each country can present their state-of-the-art status or activities at the moment. So we have currently 12 reports. So we will start with China, which will be presented by Professor Dong Wang online.
Can you hear me?
Yes.
Yes. Okay. I will share my screen. Oops. Okay, hello everyone. My name is Dong Wang from China, and on behalf of Professor Ai-Ju Li, I will report the progress in the last year from China. And the first one is from Institute of Linguistics, China Academy of Social Science, and the special corpus is called Tangut, and this corpus is mostly about linguistics, including many characters, lexicon, and parallel data, and then mostly used for analysis of the Tangut language. And the second one is from Jiangsu Normal University, and this is another interesting one is called Tongji Game Corpus, and it's recording of some conversation speech with two computing game. One is picture ordering, and the other is picture classifying. And you can see on screen that there are several pictures, and the participants are required to order classify the pictures, and the characters and the speech were recorded. And another one is from Institute of Ethnology and Anthropology, also from Chinese Academy of Social Science. And this including two parts. One is mostly OCR data from some Tangut Ancient E OCR data, and also some OCR of all the characters. And also they constructed some knowledge graph that were used to support the research in linguistics. And this is from our group. It's from Tsinghua University. It's called CNCVS3. It's Chinese Continuous Visual Speech Dataset. We have published two datasets already, and this is the third part. In total, we have released about 3,000 hours of data, speech data, with both visual and speech signal. So we can use the data to train visual speech recognition system or visual speech, visual to speech data. It means that you can convert the visual information to speech signal directly. Also, we organized the third CNVSR challenge, and you can see that with 3 years of challenge, the performance has been improved significantly from more than varied from more than 40 to right now 20. So it's quite a big drop. And in China, there are also many commercial institutes, some commercial companies. They provide a large amount of data. For example, the data ocean, first is called speech ocean, but right now they extend their scope from speech to image and also to some actions of linguistics. They provide a large data corpus. And also AirShell, they provide many non-commercial data, public data, and support the research institutes. You can download from them without any money. So Magic Data is a young company. They also provide some public data and commercial data. And DataTown is another big name in China. They provide quite a lot of data, and also the price is not so much. Another interesting trial in last year is the China Computational Federal. It's called CCF. It's they tried to organize a challenge about the advanced audio processing. This year there was two tasks. One is audio reconstruction, and in that to reconstruct the original audio from the in-house data. And also the second task is universal audio separation. There were speech and also music sources, and mix them together and try to separate them. They attracted a lot of registrations, more than 140, and they provide the collaboration is with Huawei company, and also some support from research institutes, including our institutes. And the result is quite successful. The performance was improved quite a lot from the baseline. I think this is a good trial. Okay, this is from China.
Thank you very much for Professor Dong Wang. So let's close the. So next one is from Hong Kong. Professor Tan Lee unable to join, so I will present the Hong Kong region report on behalf of Professor Tan Lee. Okay, so this is the region report from Hong Kong. How to take next? Okay, so the first one is the phonetic study on syllable initial coronal nasal and lateral in Beijing Mandarin, Hong Kong Cantonese, and Changsha Xiang. So this study investigates the phonetic characteristic of the syllable initial coronal nasal N and lateral L in 3 Chinese dialects. So Mandarin, Beijing Mandarin, Hong Kong Cantonese, and Changsha Xiang. And so this comparison, the articulatory, the aerodynamic, and the acoustic characteristic in different vowel and tonal contexts. Next one is the Okay, so next one is articulation and acoustic on Cantonese vowels in different prosodic domains. So this study investigating the articulatory and acoustic characteristic of Cantonese vowels in 3 lengths produced in different prosodic domains. Articulation is the contour and exhale position of tongue. And then the acoustics is with the vowel formant frequency. And then the 3 types of Cantonese vowels, the long in CVC syllables, half long, and also short in CVC syllables. And last one is the in prosodic domains, which is monosyllabic words, disyllabic words, and international phrases. No, this is break. Okay, so then the next one is the human versus AI, is a speech register and speech accommodation in human-machine interaction. This is done by Peggy Mork and Tan Li from Chinese University of Hong Kong. So this study investigating if there is an AI-directed speech register in Cantonese and speech accommodation patterns in human-human versus human-machines interaction for different age group, children, young adults, and the elderly. And so it's try to explore if different emotion, negative versus neutral, would elicit different degree of speech accommodation in human-human and human-machine interaction. Okay, so the next one is the, also this is the picture of the comparison of the human-human and human-machine. So in this case, the person here is have with the human interlocutor. So maybe I can we play? From the video.
今次又唔過三啦，啲又走堂去旅行，我睇死你今次又唔過三啦。真係唔明你諗咩？想野餐去未圓湖咪得咯，使乜走咁遠啊？嘥錢又嘥力。
Okay, so I don't understand Chinese, so I don't know whether this is okay. So next one. Yeah, so this have been developed, the HK Canto Eval is a benchmark for evaluating Cantonese language, understanding and cultural comprehensive in LLMs by Cheng Sung Seng, Sung Sing Cheng, Chak Ming Lau, Nguyen Tin Hao Lam, Chat Yat Wong, Hao Dong Wu, and Chok Hei Chong. So this is collaboration between Kyushu University, Hong Kong SAIS, Education, University of Hong Kong, Independent Researcher, and Ford AI and B4AI. So this is a special group of people with unusual background. So none of them actually research training in speech technology, but they are evaluating performance of state-of-the-art LLM on Cantonese language understanding tasks. So I think this is the end of the region report from Hong Kong. So next one we go to India. So I think Professor Agrawal joined online, but I think the presentation will be done by Professor Priyanko. Is Professor Agrawal say something? Maybe if he wants. Professor Agrawal, do you want to present by yourself? Or maybe difficult?
No, I request Dr. Priyanku to present the report.
Yeah, okay. So thank you for joining us online.
Yeah. I'm listening online. Yeah.
Okay.
Hello? Yeah. Okay, thank you. So as you can see, this is a report prepared by Professor Agarwal, SS Agarwal, and Professor Samudra Vijaya. I'm just presenting it. So it is the report on India. Okay, so you may not see the whole screen here, but I would like to draw your attention that the Indian government, specifically with the collaboration of the Ministry of Electronics and Information Technology, they have taken a big project at this point of time, which is called the National Language Translation Mission, which encompasses machine translation, speech-to-speech translation, ASR, TTS, and many other aspects. So that one of those initiatives is the speech technologies in Indian languages, which has about 23 institutions, including my home institution, IIT Guwahati, which is also a part of this project. So we have been doing several projects about, if I remember it correctly, about 13 different projects under the speech technologies in Indian languages. And as part of this project, already some amount of data have been collected, as you can see on the right side of the screen. For the major languages, which are the scheduled languages of India, there has been about 3,000 hours of data which is already collected. And much of this data is also transcribed, so it's a great resource that has been generated during this project. And again, as I said, that there are spin-off projects under each of these speech technologies in Indian languages project, which is contributing to different areas. Another interesting project that is happening in India is that AI for Bharat, which is basically a research lab at IIT Madras. They have been also building quite a big corpus and putting a lot of their tools and applications online. So as you can see on the left side of the screen, you can see the different data sets that they have created. And if you look into the table in the middle of the screen, then you'll see the number of speech data that has been collected from various sources here. If you look at the bottom of the screen, you'll see that Mahadhwani, there is this corpus they have collected, which is about 279,000 hours of raw audio across 22 Indian languages. Out of this 279,000 hours of data, 6,000 hours of data is already transcribed and which can be used to put to use for different development processes. Apart from that, as I have said, that under NLTM itself, there are quite a few projects, and they are not only are concerned about the major 22, 23 languages of India, but also the languages which do not fall into the major languages, such as the Tibeto-Burman languages we have been talking about in this particular conference quite a few times. We have been creating MISO database for ASR, basic level ASR, and then limited domain ASR system. At the same time, MISO, we have a good collection of TTS database also that has been developed in the last 1 year. In case of Angami also, we have collected ASR, we have created ASR database, and then currently we are trying to create one more TTS database for Angami language. And for the Ao language, which is one of the major languages in Nagaland, which is one of the Northeast Indian states, we have got 3 dialect data. We have reported only 2 dialects here, but there are 3 dialect data that we have, and we have been doing some dialect identification work on these languages. If you see on the right side of the screen, then you'll see a kind of a list of languages which belong to Tibeto-Burman, Indo-Aryan, Austroasiatic, language families which are spoken in the northeastern part of India, and we have been creating databases for these languages. Several of these ones we have been able to create limited domain ASR systems for these languages, and also language LID and dialect identification systems. So our focus in India has been mostly gone to the cross-lingual studies. In this conference, you must have already seen that we have been talking about the influence of different Indian languages on English spoken by Indian people, and also now we are also looking into the Hindi spoken by different first language speakers of Indian languages. Again, other fundamental studies, again, a sample of which you must have seen in this particular conference is that we have been looking at the tones, tonal co-articulation, vowel dynamics, then again consonantal characteristics, very ground level analysis of different Northeast Indian, specifically the low-resource languages, as you can see here. Apart from that, we also have works that are being done on Sylheti language, which is also spoken in the Sylhet district of Bangladesh and many parts of Northeast India. One interesting study that has come up, and like Esther has collected a very good data set on the folk songs that are being sung in the Mizo language. And that is very important because a lot of folk songs actually have a lot of linguistic characteristics preserved, including prosodic characteristics such as tones. So it is important for that. We are also involved, we are trying to put a lot of stress on speech technology for healthcare at this point of time. So several like pathological conditions and databases are being created for that. And again, like, ASR systems and ASR systems and diagnosis systems using speech are being tried at various Indian organizations. And most of these studies actually have come from as an initiative from the medical domain because people wanted to have these kind of diagnostic systems in the medical schools. That the push has come from the medical practitioners actually. So this is, I think, all I have. One last point is that this is a newly developed project which is called the COIL-D project. And this is again to develop parallel text and parallel voice corpora in Indian languages. This is also comes under the earlier talked about the NLTM system I said earlier. So in this case, however, the source language in this case is considered to be Hindi. So Hindi into several different Indian languages, we are trying to create parallel corpus. IIT Guwahati is also part of it, and we are doing right now work on Assamese, Boro, Bengali, and Nepali language. We are being assigned that job. So we are collecting a lot of text data, we are collecting speech data, and text data alignment is what is happening at this point of time. This is also supported, as I said, as part of the NLTM project by Ministry of Information Technology. I think this is all I have. Thank you so much.
Okay, thank you so much for Professor Priyanko and also Professor Agrawal for sharing us the national project in India. So the next country region report is Indonesia by Professor Hamam Riza.
Okay, thank you, convener, Prof. Sakriani Sakti. So, ladies and gentlemen, greetings. Very good morning to all of you. It is an honor to present the Indonesia country report for Oriental COCOSDA 2025. This year's report reflects how our speech and NLP community continues to grow stronger, more collaborative, and more aligned with regional and global innovation. So thank you for letting us host this Oriental COCOSDA in Yogyakarta. Let me begin with progress in speech processing. Indonesia made a strong advances in deepfakes speech detection, exploring pathological cues to improve localizations and robustness. An urgent topic as synthetic voice become harder to distinguish from the natural voices. We also studied stage-wise acoustic linguistic fine-tuning for overlap speech recognition, addressing real challenges in noisy, dense, conversational environments. Okay, and Telkom University research on speech and text. We have
really a collaboration which remains a major driver of this progress. We basically try to have several research, speech corpus on early marriage prevalence in Indonesia in the cultural context of Lombok, which is an island in the eastern part of Indonesia. Machine learning modeling in Indonesian scientific article keywords, a collaboration with UMPSA Malaysia. I think this year we also contributed to the development of a 50 speaker of language corpus and strengthening regional language preservations, as well as we also discuss transformer-based chatbot developments on top of German cuisine knowledge graph, a collaboration with Esslingen University of Germany. At the National Research and Innovation Agency, BRIN, which I also belong as a principal expert engineer, there are many researchers that we are doing, mostly on how we develop the regional and international collaborations. At BRIN, several international collaborations highly noted with the ongoing research and development of FLM alignment in the context of Indonesian cultures with AI Singapore is highly noted, as well as the planned research collaborative smart grid ontology with California Polytechnic State University, Cal Poly in the USA. We are also planning to work with the International Islamic University of Malaysia, as well as other collaboration with Thailand and also UAE on explainable multimodal emotion recognitions for stress-related disease predictions. I think it is really good that this strong collaboration between across universities in Indonesia, from ITB to Telkom University and other partners, are continued expanding the scope of Indonesian speech and NLP research. I would like to highlight some of the research that are currently running, evaluating model understanding of Javanese honorifics, collaborations on scientific article keyword modeling, building a speech corpus on early marriage, like I mentioned earlier, showing how NLP contributes to the social studies, as well as the knowledge graph chatbot. At the University of Shah Kuala, where I do the research here, we have basically published 3 conference papers: hybrid transformer, recurrent neural network approaches, which deliver major efficiency and performance gains in classifying regional languages, models such as the Nusa Bird with by GRU, and also with by LSTM, achieve higher accuracy, stronger generalization, and dramatic reductions in GPU usage. In one of our findings, 4 times lower VRAM and 44 times faster training. And we also do a lot of research on hybrid Indo-Bird to demonstrate the accuracy and efficiency that can be balanced for Indonesian scale NLP tests. Last but not least, at CORICA, the Collaborative Research and Industrial Innovation in Artificial Intelligence, CORICA continues to push national AI readiness through platforms such as the chatbot, CORICA Chat, built with the collaboration with Glare.ai, which is one of the sponsors here at Oriental COCOSDA 2025, with Datasore.ai. KChat delivers secure, intelligent digital transformations. You can basically ask many things about the Indonesian AI journey, whether it is coming from the government or enterprises, and it will have really a grounding, supporting knowledge management and Indonesia language chatbot. We want to extend this with more collaboration towards the LLM alignment and national data sovereignty. I also need to mention one of the apps for the speech summarization developed by Bahasa Kita, which is dictate.in. It's smart solutions for more effective meetings. I think it has gone for one of the strong applications that we can find for Bahasa Indonesia. So taken together, this achievement show three things. I have make notes here. Indonesia is strengthening its research capacity, expanding international partnerships, and building practical speech and NLP innovation that serve society. So thank you, and I look forward to deeper collaboration with all of our members at Oriental COCOSDA in the coming years. Thank you.
So thank you very much for Professor Hammam Reza. So the next country and region report is from Japan, which will be reported by Professor Satoshi Tamura.
Okay, good morning again. So I'm Satoshi Tamura from Gifu University, Japan. So until last year, the country report from Japan was introduced by Professor Nakamura, but this year, so I will introduce the recent activities related to the speech and text corpora in Japan. So I'm afraid now we are behind the schedule, so I briefly introduce the recent activities, Japanese activities. Okay, the first page is related to NII, the National Institute of Informatics. So in the past, NII, SRC is a Speech Resources Consortium. The consortium is responsible for the distribution of speech corpora, but now the SRC is integrated into the IDR, informatics research data repository. Also, IDR is handled by NII. So IDR started to distribute not only the speech corpora, but also video databases, including dialogue corpora. So in terms of the dialogue corpora, so you can see some data sets. Maybe in this slide, we have 4 data sets. And also they have R&D center for large language models. Now the large language model is a very hot topic, not only in some advanced countries, but also in all the countries, including Asian countries. So Japan is also interested in building the large language models for Japanese. So we are collecting the multimodal dialogue data set and so on. Okay, here is a list of speech corpora distributed by NII. We have in total 42 data sets, and as of August 2025, they observed roughly 5,600 downloads of these data sets. Next is NICT. NICT is the National Institute of Information and Communication Technology. Okay, they has some project named Aladdin. Aladdin stands for the Advanced Language Information Forum. So they provide some speech data sets listed in the first column, and also softwares to handle these speech data sets. And they made a global communication plan to 2025 related to these speech data sets. I'm not sure you know, but this year, so Japan had an expo in Osaka. So and NICT is located near Osaka. So they focused on some speech text technology for this expo. Unfortunately, I could not participate in the expo, but I saw one demonstration in the domestic conference. Maybe I think they also presented some demonstrations and activities in the expo. Next, this slide shows some activities in University of Tokyo and Keio University. I think they are conducted by the Professor Takamichi. And as you can see, we have some data sets and some tools. For example, the first one is related to the foundation models of speech or text. And speech dialogue, audio recognition synthesis data sets are also available. The interesting data set is the multimedia, the manga box, and also they provide some tools to handle these data sets. I think maybe this is the last slide from the country report from Japan, other research projects in Japan. So the first one is a project founded by our government. The name a study on multimodal automatic simultaneous interpretation system and evaluation method. I think maybe this one is handled by Professor Nakamura. And this is last year of this project. If you are interested in, please ask him later. Next one is the JST project, JST Moonshot R&D program. This is a 10-year program managed by Professor Ishiguro. The title is Avatar Symbolistic Society. The last one is a Ninja. This is a 6-year project. The name is Large-Scale Corpus of Everyday Japanese Conversation for Children's Speech. The project is handled by Prof. Koiso. They record some children's child speech data. You can see some pictures in the recording examples. They are collecting this data, and I think we will soon use these data sets for research use. Okay, that's all. Thank you.
Thank you very much, Professor Satoshi Tamura. So next one is the country region report for Myanmar. So I think Professor Winpapa is here, although we will play the video. Professor Winpapa, how are you?
Hey.
Hi, how are you? Thank you for joining us.
Yes, I'm great, but there is no electricity at the moment, so it's better to play the video for me.
Yes,
Thank
yes.
you.
So we'll play the video.
Good morning, everyone. I'm Wim Papa from NSBU, representing Myanmar. I'm going to present Building Language Resources of Myanmar we have been preparing. UCSY has different dataset of Myanmar speech processing, including ESR dataset that is recorded and spoken by more than 400 speakers for different domains such as broadcast news, daily conversation, storytelling, interviews, and primary education with a size of 118 hours with more than 125,000 utterances. The speakers are ranged from 5 to 75 years of ages from different regions recorded in different environments. We are preparing the first code switch data set. The name is MEASR. It includes English and Myanmar languages in IT domain recorded by online IT lectures, and it has 68% of code missing, and it is intra-sentential code switching data set. The paper is published in this conference. And the next one is M-diarization. That is the Myanmar diarization data set with a size of 41 hours by 443 speakers. It is collected from public TV interviews, question and answers during seminars at the university. It has different overlap ranges, as we can see in this table. We are developing end-to-end speaker diarization with multi-scale decoder. The table shows the evolution of the dataset in diarization error rate in different scale settings. This slide shows Myanmar spoof dataset that is the output from spoof detection for automated speaker verification project that is funded by ASEAN IFO 2023-2025. Collaboration with Thailand, Indonesia, Brunei, and Japan. The dataset consists of 4,200 utterances from 42 Burmese speakers containing 21 males and 21 females. Each speakers recorded 100 utterances, and it is represent bona fide data. So there are 7 training models by both pre-trained and fine-tuned versions to produce the spoof data derived from 2 voice conversion systems. The paper is accepted at the ICEIT 2025 conference. I am starting a new laboratory at NSBU since the beginning of 2025, and we are preparing 2 datasets. The first one is NSBU Tech Talk dataset. The objective is to improve Myanmar automated speech recognition and speech translation performance. It contains video recordings from the speakers, from industry and professors and students. The domain is science and technology. And the second data set we are preparing is optical character recognition data set that is to help developing a document management system for confidential office letter images. These 2 projects are supported by the Ministry of Science and Technology, Myanmar. Thank you so much for attention.
Hi everyone. My name is Chao Yiwen, and I'm a second-year PhD student from Nanyang Technological University under the supervision of Professor Cheng Ying-Xiong. Today, I'll be presenting the 2025 Country Report for Singapore. In this report, I'll give a quick overview of our recent developments in spoken language data. We'll cover 3 key datasets: MMAR, FDbench, and Chai Story, each representing a different frontier in deep audio reasoning, full duplex spoken dialogue, and expressive speech synthesis. First, I'll introduce MMAR, a challenging dataset for deep reasoning in speech, audio, music, and their mix. MMAR is a dataset of audio question-answer triplets with detailed chain of thought annotations, covering diverse reasoning types across the mixed modality audio, all collected from real-world internet videos. Here's an example of the dataset. The question is, a stone is dropped at the same time a person starts speaking. Based on the sound, estimate the depth of the well. Let's listen to the audio.
请根据回声算出这个井的深度。
The reasoning part measures the time between the falling sound and the echo, applies the free fall equation and the speed of sound, and finally finds the correct depth, which is answer C, 200 to 300 meters. This shows how MMAR captures multi-step physical and perceptual reasoning, combining acoustic cues with logical inference. MMAR includes 1,000 questions, about 5.5 hours of audio. All annotation and reasoning chains are manually curated and verified by human. As for the application, MMAR established the first benchmark for deep reasoning in audio language models, revealing the reasoning gaps in current system and guiding the future audio language understanding. This work was accepted at the NIPS 2025 and is open source on GitHub. This slide gives an overview of the MMAR dataset design. MMAR covers 7 modalities, including speech, music, and sound, as well as their various mixed combinations, ensuring the rich cross-modal diversity. In the center, you can see our text taxonomy, which is organized into 4 layers: the signal layers, the perception layers, the semantic layers, and the cultural layers, with a total of 16 subcategories, ranging from counting and statistics to emotion and intention understanding. Next, I will introduce the FDbench. FDbench is a dataset designed to evaluate full duplex spoken dialogue system under realistic interruption-rich conditions. It simulates natural multi-round dialogues and includes 1,200 annotated interruptions spanning 5 natural types, making it well-suited for testing real-time responsiveness and interruption handling. Here's an example from the datasets.
Hey, how can I help you?
Any advice on starting a meditation practice?
I'm glad you asked. Meditation is a great way to improve your mental and physical health. The best way to start is to choose a time of day that works for you.
Help with stress?
Absolutely.
Relief?
Meditation can help reduce stress and improve your overall well-being.
It illustrates how the user interrupts the system mid-response and how a full duplex model is expected to react, either pausing, resuming, or reformulating its reply based on the interruptions. FDbench contains 293 conversations, 1,196 turns, 73 speakers, and about 40 hours of audio. As for the application, FDbench enables benchmarking of interruption robustness and real-time responsiveness in full duplex dialogue system. It also supports analyzing model behavior across different interruption types, difficulty level, and noise conditions, and also can be used to train or fine-tune full duplex spoken dialogue systems under realistic conversational scenarios. This work was accepted at Interspeech 2025 and is open sourced on GitHub.
Hey, how can I help you?
Next, I'll introduce Chai Story, a fine-grained expressive dataset for Chinese storytelling speech synthesis. Chai Story is a comprehensive audiobook corpus that captures rich paralinguistic cues, for example, laughter and sighs, as well as various environmental sounds. Here's an example from the datasets.
怎么，我为了你特意找来这一堆眼珠子，那可是拿耳环换来的。
This segment from The Return of the Wrong Souls shows the detailed annotation for expressiveness score in intonations, rhythm, emotion, difficulty, and speaker traits. Chai Story contains 84 stories, totaling 13.9 hours of audio, with each story averaging 10 minutes and about 30 sentences. In terms of the application, Chai Story supports expressive Chinese TTS, emotion modeling in dialogue system, and various texts such as novel to audiobook generation. The dataset is planned for submission to ACL 2026 and will be open sourced soon. Okay, thank you. And that's the end of our presentation.
Okay, thank you very much. So the next country region report is by Taiwan by Professor Hin Ming Wang. Oh, Yung Paula, I'm sorry.
Hello, everybody. I'm Yuan Fuliao from Taiwan. I will report some TOPOS projects done in Taiwan. The first one is Formosa Educational AI for Revising Indigenous Language. This project is done by Dr. Yihao Xiao from National Applied Research Lab. The budget of this project is about $500,000. So this is a large project. And this project has phase 1 and phase 2. In the phase 1, they have already covered TOPOS from Turutu and Zhouzhou for about 100 hours for ASA for each language and about 20 hours for TTS. And in the second phase of this project, they will continue to do the same thing for Ameizhu and Taiwan and Bulongzhu language. And the target of this project is to build ASA, TTS, machine translation, language model, and speech-to-speech model for education, to teach kids to learn those endangered languages. And this one is also for Formosan language. This is a Formosan language AI project. And this is an amazing project because they have a very large database. They have about 700 hours speech for ASA project, for building ASA model, and also about 7 hours speech for building the TTS project. So this is indeed the treasure of the Taiwan. And they will release the TOPOS and the model about in the end of this year. So we will very soon will have those TOPOS and the model. Sorry, I forgot to mention. This project is done by Yishuan Keji, and the budget is about $600,000. And this is about the Taiwanese. This is my project. It's Taiwanese across Taiwan. We call TAT project, and this now is the phase 2 of this project. And so far, we have covered about 2,500 hours from PTS Daiji TV channel. So this is the broadcasting database. And from those 2,500 hours, we transcribe and already got about 40 million character, Chinese character. And so we use this one to build ASA model. And this project also try to build machine translation corpus. So far, we have about 1 million character between Taiwanese and Chinese. And we also do Taiwanese POS tagging. And so far, we have about 250,000 character for this part, this purpose. And I want to mention, by executing those projects, we now have several commercial products. They are available in Taiwan. The first one is a meeting mini editor. So you can record your meeting and he will translate everything into digital form. And we also have a video subtitle editor. And we also have a real-time keynote translator. And those tools are multilingual. It can recognize Miss Mandarin, Chinese, Hakka, and English. And about the future work, we want to use those corpus and develop an AI tool to do AI power Chinese language learning. And this one is about HATA. We have a HATA across Taiwan project. This is also the phase 2. In the phase 1 of this project, we already covered Sixian and Hailu dialect. And the phase 2, we handle the left three dialects, including Dapu, Zhaoan, and Raoping. And for each dialect, we will cover about 200 hours for ASA and about 60 hours for TTS. And by the way, we use the collect data to host a HATA ASA challenge this year. We are very happy. We have 70 participants this year. And the best team already pushed the world error rate to under 8%. So that's a very good performance. So we mentioned could have some commercial product also. And this is another project about the test corpus. We have a Taiwan Tongue project. It's hosted by IMA. IMA is the Information Management Association of Taiwan. So far, they have collected about 6 million Taiwanese characters from 17 Taiwanese authors. So we could use this corpus to build a large language model for Taiwanese. And they have also have a very very big project to try to build Taiwanese Wikipedia. So they try to translate Chinese wiki to Taiwanese. And so far, they already have translated about 120,000 wiki articles. And this is translated first by machine translation, then proofreading by human. And we also have another project is about smart medicine. This is done by Professor Zhao Hongjie. They collaborate the dialogue between doctor and patient. So far, they have about 10 hours. They also host an AI type challenge use this project. And this is my last slide. We also have a project about Mazu language. Mazu is a small island very close to mainland China, far away from Taiwan. But they have a Mindong dialect. It's a very different language. And so far, they have collected about 70 hours speech data for build for this language. And the last one is the common voice. Mozilla Taiwan now have the project to collect indigenous language using the common voice platform. And so far, they have collected 6 indigenous languages. In total, 74 hours in common voice version 23. And we are very happy because Meta have released Omnilingual ASA. I think it's this week. And they already adopt this database to build the Omnilingual ASA. So Omnilingual ASA can now recognize 6 indigenous languages from Taiwan. That's all. Thank you, everybody.
Okay, thank you very much for Professor Yongfu Leo. So next, with the country report from Thailand, which is presented by Dr. Chai Ainun Damrongrat.
Hello. Today, Thailand mainly contribute on the text and visions. The first one is Chinese-Thai medical parallel corpus. This one, we mainly focus on the dialogue from the doctor and patient. And the dialogue is come from China. And then we translate into Thai and use it in the medical domain mainly. And the corpus can be downloaded on the website for thai.in.th. The second one is from the vision. This is the corpus that related on the face recognition. The face is based on the Thai famous person, the star, that with the different scenarios, for example, from the social media and the television, digital television, then we can have the same person in a different scene and different style. This corpus is come from the almost 4.6 thousand video clip, and the unique people is around 1.5 thousand people. The video is in total around 7 hours and 20 minutes. The next one is the Thai Sign Language corpus. In Thailand, the sign language is, they also have a dialect. Then we select one of them, and to decide the sign language is like divided the vocab, the word, into gloss. Then it's called gloss. And the gloss, there are three different gloss type. The first one is the non-word. It's like an action to represent the word. This is the first type that we present in this corpus. The second one is the finger spelling. For example, when we want to explain the name of the place or the person, then it has a spelling. This type is used finger spelling. And the last type is the text explanation. For example, some word is not a known word, then they have to explain their action. For example, the for the farmland, for example. And when we combine this gloss, and then we also have the labeling for the gloss in Thailand. Then we have the transcription between sign language and Thai sentences. And another one is mainly for the QA corpus. Yesterday I also present this one. We focusing because the LM is coming and we are lack of the Thai corpus for fine tuning. Then we decide the man-made corpus that divided into actually eight smaller corpus. And mainly we focus on QA, but we also have another like sentence analysis and NLI, natural language inference as well. And this corpus will, because it's mainly to man-made, but we also has another labeling. For example, domain and the UKDW pyramid level as well, and formality. And this corpus is almost 132,000 pair of sentence. And for the corpus of the machine translation, Chinese Thai in the medical domain and QA, we also use in the Thailand benchmark program for the hackathon event. Thank you.
Okay, thank you very much. So next one is the country region report from Timor-Leste, which is also reported by Professor Satoshi Tamura.
Okay, hello again. So, unfortunately, the representative Alice Jesus Ornai, he could not come here. So, on behalf of Timor-Leste researchers, so I will have a presentation about the country report from Timor-Leste, because I and they have research collaborations supported by the Japanese Affairs. Okay. So first of all, this is the introduction of Timor-Leste. So Timor-Leste has 1.4 million citizens. Still, the population is increasing, and the official language is the Portuguese and Teton language. And they have, in addition to the Teton language, they have about 30 local languages. And we focus on not only the Teton language, but also local languages. And in terms of the speech and NLP applications, so far, we have Google Translate. They started the service since 2024. But as long as we know, there's only the application for Tibetan language. So in terms of the speech recognition data set, we have already collected some data sets for some local languages in addition to Tibetan language. But the vocabulary is limited, for example, the greetings or common word and so on. So in terms of the spontaneous speech corpus, so we are now collecting the Tibetan speech data from news channels on YouTube. So far, we got roughly more than 100 hour data, but still only a few data are transcribed. So we are still continuing to get the transcriptions of the other unlabeled data, and also we are conducting research works using these data sets. I hope we will have some presentations in this conference next year or near future. So in terms of the speech synthesis, now the Timorese researchers starting to collect some speech data for speech synthesis. So far, they got the speech data from 10 speakers, including 5 female and 5 male speakers. Also, they are now conducting the speech synthesis research works for Tibetan language. I hope also they will have some research progress in this conference or in the other conference in the near future. Next, the text corpus. The text corpus is very important also for speech processing in addition to natural language processing. So Tibetan text corpora have been also developed for these purposes. As long as we know, we have 3 Tibetan corpora listed there, and one of them were presented in this conference. So now we are continuing also to collect much more text data from many resources. I hope in the near future we will also have large language models for Tibetan language. So final, this is the last slide from the Timor-Leste country report. The future works includes the refinement of the new speech data set, and also we need to work for speech synthesis. The last one is to build the large language models for Tibetan and use the large language model for the speech recognition and NLP as well. That's all. Thank you very much.
Thank you very much. So last but not least, we will have the country report from Vietnam. So I think Professor Do Van Hai is here. Thank you for joining us. So, but we will play the video.
Yeah. Hello. Yeah, that's play beautiful for me. Thank you. Hello everyone. We are Do Van Hai and Professor Leung Chi Mai. We will give some updated activities in Vietnam recently. Since 2021, Vietnam has been implementing its national strategy on AI research, development and application until 2030. Both academia and industry are actively contributing through various events. Vietnam has made significant progress in developing NLP datasets. Here are some key contributions. VFact presented the Vietnam first fact-checking benchmark dataset with over 7,000 human annotated claim evidence pairs across 12 news domains. VISP is a large-scale sentence paraphrasing dataset with more than 1.5 million original paraphrase pairs. Vietnamese English cross-lingual retrieval introduced datasets for cross-lingual document retrieval in general and legal domain. VMLU benchmark at ACL comprehensive evaluation toolkit for Vietnam LLMs covering multiple choice questions, reading comprehension, reasoning, and dialogue dataset. In speech processing, Vietnam had developed several impactful datasets. VTOSHA, introduced at InterSpeech, is the first dataset for top 6 spam detection in Vietnamese speech. First, audiobook presented at ACL introduced more than 900 hours of high-quality audio for text-to-speech. Multimed, a multilingual medical ASR dataset, feature 150 hours across 5 languages, including Vietnamese. VIMD capture many dialects from all 63 provinces in Vietnam. Other notable datasets include VSpeech and VVoice, supporting ASR and multi-speaker TTS development. Moving to the 11th VLSP event held last month, several text challenges were presented. Deep retrieval in legal landscape, developing Vietnamese legal small language models, numerical reasoning, and temporal questioning and answering, semantic phrasing, and medical domain machine translation with limited pre-training. The last challenge is a multimodal legal question answering, focusing on traffic sign rules. The VLSP also introduced speech challenges such as spoofing aware speaker verification, voice conversion, automatic speech recognition, and speech emotion recognition. And this year, we first introduced speech quality assessment to estimate telecommunication channel quality using only audio signal. We have presented a paper about this techniques today ago. That's a summary of our recent activity in Vietnam. Thank you very much for your attention.
Thank you very much. So we would like to take a photo of the country representative. So I hope Professor Dong Wong, Professor Win Papa, Professor Agrawal, and Professor Don Van Hai can turn on your video. And the other country representative, please come to the stage. We will take a photo together. So, Professor Priyanko.
Yang itu apa? Country rap-nya. Ya. Jadi ada Sam Agrawal,
Yeah, we are pinning Professor Agrawal, Professor Wang Dong, Professor Win Papa, and Professor Fando. Yeah, we are pinning them. Yeah. Okay. Anting. Pojok kanan bawah.
Yang Ismail nggak?
Okay, there you go. We are ready.
So can the people can see? Okay. Okay. Okay.
Thank you.
Okay, thank you everyone, and thank you Professor Sakti for bringing up the session of the report. Okay, we are reminding those who are going for Friday prayers, please come to the information desk because we have the committee who are ready for escorting you to the mosque. All right. Now, we are coming to the exciting announcement, everyone. The Best Paper Award of the 28th O-COCOSDA. Are you thrilled? This year, our awards recognized outstanding achievements across the 3 paper categories. They are data, technology, and speech science. Each of these champions has demonstrated exceptional creativity, impact, and innovation. They've shown us how science and technology can shape a smarter, more connected world. So, without further ado, let's begin. Committee, are you ready? Okay. The winner of data category is Japanese articulatory speech dataset acquired with 3D electromagnetic articulography by Eri Ikeda, Yukiyusu Yoshinaga, Koichi Katsurada, and Kohei Wakamiya. Winners, are you here? If you are, please come forward onto the stage. Congratulations. Okay. And now I'm announcing, yes, is that on the stage or in front of, onto the stage, please, yes. Photographer, is that right? Onto the stage, right? Okay. Yes, yes, you can come up on the stage. All right, yep. Next, yep, the champion of the technology category goes to Exploring the Impact of Data Quantity on ASR in Extremely Low Resource Languages by Yo Weng-Cheng, Li Wen-Chen, Hu-Shin Li, and Sin-Min Wang. If you are here, please come forward onto the stage. Yes, please. Okay. Right. Please, everybody, stay tuned. Now, I'm going to announce another winner of the technology category. And it is Toward Natural Emotional Text-to-Speech System with Fine-Grained Non-Verbal Expression controlled by Wingsisi Zhou, Bagus Triatmaja, and Sakriani Sakti. Winners, please come onto the stage. All right. And next, we have the winner of the speech science category is Beijing Mandarin Stress Timed Examining Rhythmic Patterns in Spontaneous and Rich Speech by Ziwi Wang and Aijun Li. Now, I'm inviting, wait a second. Okay, I'm inviting the convener of O-COCOSDA, Professor Saktiani Sakti, to give the certificate to the winners of the data category best paper. Yes, that is Eri Ikeda, Yukiyusu Yoshinaga, Koichi Katsurada and Kohi Wakamiya. Yes, you can move to the left. Yes, so that you are in the middle of the screen. Yes, yes, please come to the left. Okay. And I'm also inviting the program chair of O-COCOSDA, Dr. Desi Pujilestari, to give the certificate to the winners of the technology category best papers. Okay. All right. Yes, the next one is Yao Feng Cheng, Li Wenchen, Xin Min Wang. That's the winner of technology category best paper. Congratulations. Okay. Yes, please stay. We're going to take a picture later on. Thank you. Yes, the next one is the winner of technology category best paper, Yao Fei Cheng, Li Wei Chen, Hung Xin Li, and Xin Min Wang. And also Wang Sisi Zhou, Bagus Triatmaja, and Sakriani Sakti. Congratulations. Okay, please stay on the stage. We are going to take a picture after this. Yes, the next one. Okay, the winners of speech science category, I'm afraid they are joining online. Ziwei Wang and Aijun Lee. Excuse me. Yes, you left something. Yes. Yes. Yes, so I think that was that all. And is there any representatives of or colleagues of the winner of technology category? Speech science category best paper. Is there any colleagues who can be the representatives of them? Please come onto the stage. No? Yes, if no, then I'm afraid they are not joining in the Zoom. Are they? Okay, if Ziwei Wang and Aijun Lee, if you are in the Zoom. Oh, they are not joining, Professor. Yes, so shall we take a picture all together? Oh, yeah, okay. All right, so somebody can be the representatives? If Prof. Sakti, maybe? All right, so Dr. Tadu will be the representatives. Thank you very much. Okay. Right, now we are going to take the picture together. So all winners, can you please stay in the middle of the screen? Thank you. All right. Congratulations once again. Yes, everybody may be seated. All right. Next, we have another thrilling moment, everybody. So, ladies and gentlemen, we are going to reveal the host of the 29th International Conference of O-COCOSDA. So, allow me to invite Professor Nathaniel Oko to announce it. So, kindly call Professor Nathaniel Oko onto the stage. Okay. Yeah, dear. Yes, we have the drum roll, Prof.
Okay. Can you please open the presentation slide? So pleasant morning again to everyone. My name is Nathaniel Ojo. I'm a senior lecturer from De La Salle University. And this morning, it is my honor to present the next edition of Oriental COCOSDA. Do you have the presentation slide? Okay. We also prepared some video which are available online.
So are you ready to announce it?
Yes.
Okay. So you can call it. What country is that? And we have the drum roll.
Oh, okay. So drum roll, please. So the next host will be the Philippines, and it will be held in Mactan Island. Do you have the presentation slide? No
We
presentation.
don't.
So just this one.
Just that one.
Okay.
Yes.
Thank you very much.
Thank you, Professor Oko. Okay, right. Wait a second.
Yes, yes. While they are preparing, I would like to mention that I like my T-shirt. Do you like your T-shirt? Yes. Okay. Yeah, I also like my cup. Yes, the cup, and the fan. So next year we are pressured to also provide T-shirts. So just to give you a quick background, Oriental COCOSDA 2026 will be held in Mactan Island. Mactan Island is in the province of Cebu, Philippines. Tentatively, we are scheduling it during the last week of October 2026. The organizers are De La Salle University and University of San Carlos. Some local information, Mactan Island, since this will be in October, it's near the end of the rainy season. The airport is serviced by Mactan Cebu International Airport. The resort, we are planning to host it in a resort. The resort is tentatively around 15 to 20 minutes from the airport.
Yes, Prof. Oko, it is
Yes.
ready.
Okay, thank you very much. So, $1 is estimated to be around 59.20 pesos, and the current mode of transportation, we have jeepneys, we have taxis, buses, we also have transportation apps like Grab, and the temperature ranges from 24 to 31 degrees Celsius. So Mactan Cebu International Airport has direct flights to China, Taiwan, Japan, Singapore, and other Asian countries. Now, in 2019, we hosted the Philippines, where we were able to invite at least 300 attendees. Now, activities in the island include island hopping, we have snorkeling, scuba diving, and then near the province, we have other options like canyoneering, and we also have chocolate hills. So Professor Agrawal, when we hosted it in 2019, was able to visit this one. So we have here a video, so I hope you will enjoy, just to give you an idea on what to expect in Cebu Island.
Sige, diretso!
So, looking forward to welcoming you all next year in Mactan Island, province of Cebu, Philippines. Thank you very much.
Okay, so congratulations once again for the winners of the best papers and the host of the 29th International Conference of O-COCOSDA. So, ladies and gentlemen, as we come to the final moments of our conference, we've had the opportunity to share ideas, build connections, and explore inspiring perspectives from around the world. Now, to officially bring this remarkable event to a close, it is my honor to invite Professor Sakriani Sakti to deliver the closing remarks. So please join me in welcoming her onto the stage.
Okay, ladies and gentlemen, distinguished guests, speakers, and participants, as we come to the end of COCOSDA 2025 conference, it is my great honor to deliver the closing remarks. So first and foremost, our deepest gratitude goes to all authors, presenters, and session chair. Your contribution through high-quality papers, insightful presentation, and dedication moderation have been essential to the success of the event. We also sincerely thank you for all participants for all the active discussion, truthful question, and valuable contribution throughout the session. Your engagement has enriched the exchange of knowledge and strengthened our community. We extend a great thank you to our host institution for their unwavering support, the Collaborative Research and Industrial Innovation in AI, CORICA, and Faculty of Information Technology, Universitas Kristen Duta Wacana. Your support has made it possible for us to organize and run this event smoothly. So a big thank you goes to our sponsor for their generous support, Claire AI, Goto, Arcadia, and the IEEE Indonesia section Computer Society chapter, and the Indonesian Association for Computational Linguistics, NACL. So we also offer a great thank you to Oriental COCOSDA Steering Committee, Oriental COCOSDA Country Representative, and the International Advisory Program Committee for their dedication, guidance, and continued support. Okay, so now we have to thank who is behind all these things, the organizing committee. I hope you all stand up. From the Honoris Chair, Professor Hamam Riza, General Chair, Dr. Muhammad Teduh Uliansa, Associate Professor Esti Dianto, Program Chair, Dr. Desi Puji Lestari, Dr. Ade Romadoni, Dr. Khalid Mukhtar, Dr. Gloria Virginia, Publication Chair, Dr. Dery Wijaya, Dian Isaini Nurul Afra, Dr. Halim Pudia Sonto, Financial Chair, Dr. Ari Ardianti, Sponsor Chair, Lukman Nasir, Local Arrangement Chair, Dr. Antonius Rahmat Krismanto, Publicity Chair, Dini Fronitasi, Lucia Dwi Krisnawati, Rahmat Abdul Ramadan, Secretary Christian Cecilia Munti, and Webmaster Siska Pebiana. Thank you for all your tireless effort behind this scene. And finally, I would like to thank our volunteers there, maybe on behind. Thank you for your dedication, energy, commitment. You play a crucial role in ensuring the smooth running in the conference. So with this, we officially close the conference, which is quite sad because this means that we have to separate again. So we hope the discussion, connection, and collaboration formed here will continue to grow and inspire future work. And we look forward to seeing you next year at the Oriental COCOSDA conference in Cebu, Philippines. Thank you.
Okay. Thank you, Prof. Sakti, for the closing remarks. Now, the Committee of O-COCOSDA 2025 is delivering a token of appreciation to the Faculty of Information System and Technology. So I'm inviting the Dean, Bapak Restian Dito Eskom MSis PhD, to come in front, and also Professor Hamam to give the token of appreciation. Yes, onto the stage, please, for the sake of documentation. Yes. Yes, thank you very much. Okay, distinguished guests, we have now reached the conclusion of the 28th International Conference of O-COCOSDA. So over the past few days, we have shared insight and built new connections. So on behalf of Universitas Kristen Duta Wacana and the organizing committee, I would like to express our sincere gratitude to everyone who made this event possible. Our speakers, sponsors, partners, and of course, all of you, our participants. Thank you for your time, energy, and engagement. We wish you all the best and hope to see you again in the future. Thank you and have a wonderful day. Yes. All right, last but not least, before enjoying lunch, allow me to spill a bit about Yogyakarta City Tour today. I'm sure everyone is excited about it. So the tour will start at 1 p.m. So for those of you who have registered, please gather at the front door of the hall at 12:30 p.m. You're going to experience one of the world's 7 wonders, Borobudur Temple. Yeah, so of course everyone has seen the picture before. So this is at the northern part of Yogyakarta. Okay. And leaving Borobudur Temple, you will also experience one of the distinctive culture in Indonesia, which is batik painting. Yes. Okay, you will see the process of making it up close. And also reminding you to bring along your O-COCOSDA cap, right, to protect your head. And also an umbrella as the rain might come. An umbrella is provided at the registration desk, so everyone please proceed to take it. And also you may deposit your suitcases in the registration desk to be taken back later at 7 p.m. after the tour. Okay, now we will take a break for lunch, everybody. So lunch will be served at the front of this hall. Please be reminded to stand by for the Yogyakarta City Tour by 12:30 p.m. as our bus departs at 1. Okay, so thank you very much and enjoy your meal.